Hi, everyone. So, welcome to the second day of the Blockchain Community Day Conference, 2026 edition. This is our sixth time in a row, 6 years we've been organizing this conference. And for the entire week, we are here making some kind of breakdown of everything blockchain related, of everything enterprise adoption related. And today we will be having 6 amazing speakers, and as well as throughout the next couple of days till Friday, we'll be breaking down things like infrastructure and scaling, AI and blockchain integration, programmable finance, interoperability policy, and of course, things like Web3 and go-to-market strategies for Web3 and blockchain projects. And I'm very happy to invite our today's guest right away, not to delay the beginning of the conference. So I'd like to ask our technical team to invite Sergey Kravtsov to the stage. Hi, Sergey. How are you?
Hi, Alec. I'm good. How are you?
Yeah, I'm good. Thanks. Thanks for joining our conference, and thanks for being here with us today. And I'm very glad to announce that we'll be having the topic about from one-time transfers to continuous value flows, rethinking payments in Web3. And to those audiences who are watching us across different platforms, please make sure to leave your questions in the live chats wherever you are watching this, be it on We Are Community platform, be it on X, be it on YouTube, be it somewhere else, or even after we publish the recordings of these videos. Feel free to join our Telegram chat and ask any questions or ask for an intro with our speakers there. And I will drop the link of our Telegram chat just in a minute in the descriptions and in the comments section. And without further ado, I'd like to ask you, Sergey, to say a couple of words about yourself, about your background, and after that, we'll be good to start.
Okay. Do you hear me well, right? Hi, everyone. Thank you for having me today. My name is Sergey. I'm the co-founder and CEO of Papaya. We build infrastructure for recurring stablecoin payments. For the next 20 minutes, I won't sell you a product. I will talk about a problem and about a way of thinking that solves it. So let me start with a simple question. Almost every business in the world runs on recurring revenue: subscriptions, salaries, rent, memberships, SaaS. This is how the real economy works. No one payment. Payment that repeat again and again. Now look at crypto. We move huge amounts of money on chain every day, but almost none of it is recurring. Almost everything is a one-time transfer. So here is the question I want to answer today. Why can't we do recurring payments on chain properly and at scale? Let's start with what already works. Sending money on chain is a solved problem. It's trivial. You call transfer, you sign, the money moves, and done. This is the primitive crypto is built on. A one-time push. The sender pushes the funds, one action, one transaction, and we got very good at this. Fast, cheap, global, and final. But here is a thing: the economy does not run on a one-time payments. It runs on payments that repeat. Your Netflix is not a one-time payment. Your rent is not a one-time payment. Your team's salary is not a one-time payment. So if we want to be real financial infrastructure, we need recurring payments. And this is where it gets hard, much harder than people think. And let me show you why. There are 4 walls. 4 reasons recurrent payments on chain are difficult. Wall number 1, pull versus push. In the normal world, a subscription works by pull. You give your card to Netflix, for example, once, then every month Netflix pulls the money. You do nothing. Crypto is the opposite. Crypto is push. To send money, the user has to sign every single time. So imagine paying for Netflix on chain. Every month you open your wallet, you sign a transaction, you pay gas for every subscription you have. Nobody will do that. It's not a product, it's homework. Wall number 2. Um, okay, you might say just use approvals. In crypto, we have a tool called approve. The user approves once. Then the merchant can call transfer from and pull the money. Problem solved? I say no, because to make this work for a subscription, the user has to approve a very large amount, often an unlimited amount. And then the merchant can take anything at any time. That's not a subscription. That's giving someone the keys to your wallet. One bad merchant, one bug, one hack, and your funds are gone. So unlimited approvals are a custodial hole. No serious user should accept that. Wall number 3, gas. And this is the big one. Let's say you solved permissions somehow. You still have to charge every subscriber every period. 1,000 subscribers, 1,000 transactions. 1,000,000 subscribers, 1,000,000 transactions. The cost grows with the number of users. In computer science, we call this ON, linear cost. Now there are 2 problems with this, not one. The first is money. A subscription is a $5 a month, but if you pay gas for every single user, every period, even 5 cents a charge, that's $50,000 a month for 1,000,000 users just in gas. The business is dead. But the second problem is worse. It's not about price, it's physics. Every block on a blockchain has a gas limit. A block can only hold so much, so you simply cannot fit 1,000,000 shards into one block or 10 blocks. You'd be spreading your billing across thousands of blocks, fighting for space with the entire network. So even if gas were free, even then, linear billing does not fit on chain. The block won't hold it. That's the wall, and it's why isn't pricing problem you can wait out. It's a structural problem. You have to remove per user transaction entirely. And wall number 4, custody. A common shortcut is to ask user to deposit money in advance. Put your funds in our contract and we will charge from there. But now the money is sitting somewhere that is not your wallet. Between charge, someone else is holding your funds. That's not a subscription anymore. That's a deposit. And deposits bring trust problem and regulatory problems. People don't want their money locked up with a third party just to pay $5 a month. So 4 walls, pull versus push, dangerous approvals, linear gas, and custody. This is why crypto subscriptions are hard. Not because nobody tried. Many smart teams tried. They all hit these walls. Now I want to change the way we look at this, because here is my main point. There are not really payment problems. There are scaling problems. On-chain computation is limited. It always has been. And honestly, it will stay limited for a long time. The blockchain will not let you look over 1,000,000 users in one transaction. It's too expensive and it's simply won't run. So if you are building anything with many participants, linear complexity will kill you. You cannot touch every user one by one. The protocols that actually scale in DeFi, all of them use algorithms with constant cost, O1 or logarithmic. The cost stays the same no matter how many participants you have. 1,000, a million, a billion, same cost. This is the secret behind the biggest protocols in DeFi. Let me show you the pattern. You can sort these scalable primitives along a few simple lines. First direction. Money can go from one to many. We call that dispersing. Or from many to one. We call that collection. Second, speed. It can happen instantly in one event or gradually over time. Now let's place real protocols on this map. One to many instant, that's an AMM. When you swap on Uniswap or Curve, you pay a fee. That fee is spread across all liquidity providers at once. 1,000 providers, a million, the cost is the same, one. One to many, gradual, that's lending. Aave, compound, interest flows slowly over time to all the lenders. Again, constant cost. Every one of these is O1. None of them loops over users. They all use the same trick, a global accumulator. You update one number and each user's share is calculated only when they interact. No loop, constant cost. This is a solved pattern. The whole industry runs on it. So now the obvious question, where do recurrent payments fit on this map? Let's see, a subscription is many subscribers paying one merchant. So the direction is many to one collection. It happens over time every period, so gradual. And it's the same asset, in and out, stable coins in, stable coins out. Many to one, gradual, same asset. That's one specific cell on the map. And it's one of the most valuable cells in the whole economy because every subscription business on earth lives in it. And here is the key idea. Look at the cell right next to it. Lending, one to many, gradual. Money flows from borrowers out to many lenders, slowly over time. And we already know lending scales to millions of users at constant cost. Recurrent payments are the mirror of lending. Lending many lenders earn, one to many, gradual, or one. Subscriptions many subscribers pay, many to one, gradual. Same math, same accumulator, just flipped direction. So recurrent payments were never some deep, unsolved mystery. The math to build them correctly already existed. We have been using it in lending for years. There is just one rule. You have to build it for one. If your design charges users one by one, you picked the wrong approach and you will hit the gas wall every time. And this isn't just me saying it. This map I just described, it comes from a talk by Anton Bukov, the co-founder of 1inch. He gave it on the main stage at Ethereum Amsterdam about which algorithms actually survive on chain. Full disclosure, Anton is an advisor and an angel investor in Papaya, so of course I'm a little biased here, but look at where he put us. On his own map, in the collection cell, the mirror of lending, he placed Papaya, right next to Uniswap, Aave, Curve. And the reason he put us, there is no friendship, it's the math. Here is what he said. Collecting assets from millions of streams is the same cost as collecting from one. That's the whole idea in one sentence. No enumeration, constant cost. When the person who classifies scalable on-chain algorithms for a living puts your protocol right next to landing in the mirror cell, that's the strongest signal I can give you that this is the right cell, built the right way. So this is what we built in Papaya. Recurring stablecoin payments settled at constant cost. Let me go back to the 4 walls and show you how each one falls. Wall 1, pull versus push. The user sets up a payment stream once. After that, they don't sign every month. No homework. Wall 2, dangerous approvals. The right to charge is not unlimited. It's bounded by the conditions of the stream, the rate, the period. The merchant can't just drain the wallet. Wall number 3, gas and linear costs. This is the core. Our settlement is aggregated and O1. The cost of setting doesn't grow with the number of subscribers. 100, a million, a billion, settlement cost stays flat. We use an O1 accumulator, the same class of algorithm the whole industry already trusts. And the wall 4, custody. Papaya is non-custodial. The funds stay in the user's control until the moment of settlement. We never hold your money. 4 walls, all 4 gone. And this is not white paper. It's not a future plan. Papaya is live today. We are running on 9 chains. The settlement architecture is real, it's audited, and it's patent pending in USPTO. So the question I opened with, why can't we do recurring payments on chain at scale? And the answer is we can. The piece that was missing was never a payment feature. It was the right algorithm in the right cell. One last thought to zoom out. We started with subscriptions, one cell on the map. But the same cell, that same primitive, is not just for subscriptions. The same mass works for payroll, for usage-based billing, and for something new that's growing fast, AI agents that pay for services automatically by usage, machine to machine, many payers to one provider over time. Same cell and same mass. One primitive, many users, many use cases. So this is not just about Netflix on chain. It's about the infrastructure layer for recurring value in the whole stablecoin economy. So let me leave you with the one idea I want you to remember. On chain, linear syncing doesn't scale. Constant syncing does. For years, recurring payments looked like a hard and solved problem. They were not. They were just one cell on a map we already understood. The same O1 mass that powers lending and AMMs powers recurring payments too. You just have to flip the direction. If you are building in this space, payments, wallets, agents, think in constant cost. And if you want to build on top of it, come to talk to me. That's exactly what we are making at Papaya. Thank you.
Let me just quickly, yeah, I'm here on the stage. And yeah, thank you so much for such a short and informative overview of what you're building and what's happening on the DeFi fields right now. And I'd like to ask a couple of questions from me. And after that, I'll be going through the live chats to see if someone else is willing to ask a question, since we have something around 10 minutes before the next session. And could you please tell me the most interesting and curious one? What's the main problem of DeFi adoption right now, in your opinion?
The main problem of DeFi, last couple of years, we think about DeFi um, in terms of trading and some uh, hype stories like NFTs and something like this. But for me, it's more important to build products that everybody will use. For example, uh, for me, it's very important to start paying uh, with crypto for customer services for platforms and projects that we use every day, and it we are in big process because many central banks in Central Asia, and in other countries as well, they in process of integration these technologies, and I think that uh, crypto adoption will grow very fast next few years.
Yes, and what do you think is the main blocker for today? Is it UX? Is it security? Is it the costs, or is it regulation, or anything else? I mean, what's the main blocker for this adoption?
Yeah, very good question. I think that the main blocker is regulation, because central banks can just add DeFi rails and start working on it. So they need to prepare uh, documents, regulations, and integrate it with compliance, security, and solutions.
Exactly. I would totally agree here with you that when we speak about the technology itself, we feel like everything is ready right now, but the legal part, the compliance part, the regulatory part, the governmental activities kind of parts are lacking, and they are a bit slow nowadays. And yeah, one more question from the chat. Someone asks, why are recurring payments fundamentally harder than one-time payments in crypto?
Yeah, can I share my slide again?
Yes, it's here on the stage.
Yeah, I think that these four walls is answer these questions because you know that uh, to uh, collect recurrent payments, uh, you need to uh, you need to deal with these four walls. First of all, that it's a different architecture than in traditional finance. And the second wall is approvals and custodial wall, as I said before. The third one is the biggest problem. It's about architecture tool. It's about one complexity, because if you will have 1 million users that you need to charge every month, you need to in ON algorithm, you need to enumerate 1 million, 1 million streams or 1 million payments, and you will pay a lot of gas instead of payment processing fee. And if it would be some, I don't know, maybe a central bank fork without any gas, you can't put 1 million transactions in one block. And you can imagine that it's not only one platform. For example, 2, 3, 10 platforms will collect such many subscriptions. So it will doesn't work. So these smart contracts, as Papaya and other DeFi protocols, they we are we are uh, help to scale blockchains uh, with our solutions. And for example, with Papaya, you can collect millions of users in just one short transaction less than 1 cent on EVM chains. And it's all non-custodial.
All right. We have a couple more questions and a couple of minutes till the end of the session. Let me just quickly bring that to the stage. I'm going to hide the deck. And the question is here. Where do you expect the biggest regulatory sensitivity? Custody, consumer protection, chargebacks, or KYC?
In my opinion, for banks, is very important custody, AML, and QIC. So I think what will be next with adoption, like it would be two different directions. So DeFi will live their own life, and banks will integrate DeFi primitive DeFi protocols and do it custody, and they will the custodian of these solutions, and they will integrate KYC as well. I think this is
all right. Yeah, I believe that answers your question. Whoever asked that in the chat, make sure to bring up some details if you need. And one more question. Let's make that the last question unless anything new comes. And it says, other than subscriptions, what is the most important recurring payments use case to unlock? Payroll, usage billing, B2B invoicing, or AI agents, and why?
I think that B2B invoicing and B2B cross-border payments is a very good use case, and this is a huge amount of volume these days. And in the next future, AI agent payments is a big volume too. For example, when one AI agent pay to another agent for usage some of their skills and for example for use some memory or different different use case would be here this use case.
All right. And I think that was the last question in the chat. Anyway, whenever we get new questions, we will address them to our Telegram chat. The link is in the YouTube's live chat, wherever you're watching this. And after that, we'll be covering the rest of the questions in text. And with this said, thank you so much, Sergey, for such a great overview, such a great topic, and such a short and sweet and very clear explanation of what's happening right now and how your product is helping to solve this problem of the DeFi fields. That was really interesting, and really hope to see you on our stage again.
Thank you, Alec. Have a good day. Bye-bye.
Thanks. And just in a minute, after a 1-minute transition, we will be back with our second guest, Mikhail Tyutin. And please stay tuned. We'll be back in 1 minute. All right, and we are back here with the second talk of our today's agenda. And considering that we had a lot of questions about regulatory things, and that's some kind of blocker right now for the accelerated adoption of different DeFi protocols and all the other solutions, I'm very happy to this kind of logical continuing of the previous topic. And this time I am inviting our second guest of today's agenda, Mike Tutin. Hello, Mike. Could you please?
Hi.
Yeah, we can see you here. Hello, how are you?
Hey. Good.
Yeah, I'm very happy to see you here again on our stage, since back in 2024, some of our older audience might remember that we had already hosted a great webinar about building components of compliant DeFi. And yeah, whoever is interested in that topic, you can find that recording on our YouTube channel and on our community page on our community platform. And this time, yeah, without further ado, I'm going to just quickly ask you, Mike, about your background, about yourself, and after that will be good to start the presentation.
Yeah, thanks a lot for inviting me here. My background is in between technology and legal stuff in smart contracts and DeFi. What I'm doing is basically working a lot on regulation in DeFi protocols and in crypto in general, helping an R&D department in AML board, and also helping regulators and other authorities to deal with blockchain-based financial protocols and DeFi itself. So today, I will be speaking more about regulation and latest changes in upcoming DeFi regulation. I had a number of meetings this year with authorities and protocols themselves and founders as well. So I will bring more insights to this discussion, and I hope this will be interesting for others as well. So how can I present my presentation here?
Yes.
Oh,
I think that is here, and you're good to start.
Yeah. So decentralized finance was built so that no one can be in charge. So no bank, no broker, no operator to call, just the code, and that was a major point. It's changing. Okay. So we'll build tools and protocols that simply don't fit our existing financial system. And this system exists to regulate someone in charge. It needs a who, someone who can hold an obligation, freeze an account, keep and manage customer data. So we have a financial system with no responsible party, meeting a legal system that only works when someone is responsible for it. So for years, the question was, is it really decentralized? The regulators stopped asking it, and they now ask a simple one: who is in control? That one word changed everything. And lately, it stopped being a theory. It started sending people to prison, unfortunately. Today, we'll follow it through, and the words, the toolkit, and the verdicts. So the shift didn't start with the regulator. It started with the bank that serves central banks, the Bank for International Settlements. Back in 2021, they called full decentralization an illusion. In their words, the key players, usually the developers, are in the end of control. So let's remember this point exact. If you look closely, you can almost always find the one in control behind the DeFi protocol. The Financial Action Task Force made it a rule, so attempted to make it a rule at least. FATF set the global anti-money laundering rules. The software itself is not regulated, but the people who keep control or have enough influence over it can be. And they gave it a name, the DINO, decentralized in name only, which is a very fancy term. Back in 2023, the International Organization of Security Commission gave us a word we use today. They dropped protocol out of DeFi and started saying DeFi arrangement. And this name targeted the responsible person, which is very important. The list is wide: the founders, the developers, token holders, and the people who run the website. Why does the rewards arrangement matters? Because the protocol actually means the technology, and the arrangement means the activity and the people around it. So the things being regulated moves from code to the people who do this code and they manage the protocol. And this is the real law. FAT, the UK, and the US are all writing their control test into their rules. In 5 years, the question changes from what is the technology to who is responsible for it. And the answer is always whoever has the control. 5 institutions, 1 idea. The idea is simple. Don't sort DeFi by what it does, like lending or swapping. Sort it by how much control one identifiable group keeps. Control decides who can be made responsible for anti-money laundering. No control, no one held responsible. Full control, an obvious party, and the interesting cases sit in the middle. 2 ends, starting from the full control. Think of a venue or an operator. You ask for a trade, off-chain traders fill, and a contract settles it. It doesn't hold your funds, but the clear operator runs it. That's basically a centralized exchange living on-chain, and it can be made responsible for it. An example of such an arrangement is usually intent-based bridges, any cross-chain bridges, stuff like that. And from the other end, there are no control protocols like Uniswap. The contract can be changed. There is no block list, no switch off, no key account that used to stop the trade. Anyone can use it directly, even North Korean guys. The only checks live on the website, and no operator can control or trade on chain. Now the key point. The 5 institutions describe the same thing. The FAT introduced the term the owned operator. Another term is responsible person. In UK, it's controlling person. In US, it's control test. Put them all together, and their point is the same. 1 idea, 5 institutions. So the question is simple. Is there a company, a group behind it? And does this matter? And this is the only thing that matters. If there is one, it carries the duty. If there isn't, the regulator looks at the edges, the website, the on-off ramp, the stable coins. The one warning, control is not out of its all. It's a set of deals, the number of admin keys, the power to upgrade, a fee switch, whoever runs the website, you measure it. You don't just label it. Here's the twist to keep it in mind until the end. The word control is about to do something strange. The same fact, no one controls the code, would set the one defendant codes free and send another defendant to prison. The same fact, opposite results, same year. Once you see the define as in line in full control, no one, every fight in talk makes sense. They all answers to one question: who is in control of DeFi arrangement?
So let me check if everything's fine. Just a moment. Oh, we are causing some internet connection issues. Let's just quickly fix that. Just give us a minute.
Sorry, am I back?
Mm-hmm.
Yeah, I'm back online. Yeah. Sorry, looks like connection issues here. So you think a licensed regulated company is in case, but it isn't. But I'll skip the technical details because the real news in this one major regulator just put the control test into law, the UK. It's a new crypto rules regulate DeFi, where there is an identifiable controlling person running the activity as a business, and where is it truly decentralized, meaning no person runs the business, and it falls outside of the rules. The line we just drew is an actual outlined law. They have even promised a guide to understand who is in control of actual protocol. So even if there is a clear case, it's all about controlling person. So here on the slide, you can see 4 rings: the website, the transaction, the proof vault, and then coming in. So the website, let's take a Uniswap as example. The Uniswap checks all transactions on the website. It does the screening, sanction lists, blocking some countries. The problem is, by its own number, only about a quarter of users go to Uniswap through the website. But the website is controlled of the exact company, and this company is responsible for whatever is going through the website. So the next circle is actually the transaction circle. Here you check the rules before the transaction runs on chain. And this is compliance switch off. A transaction that breaks the rules fails before it completes, instead of being frozen later. And it still can be private. A zero knowledge check is something that can be employed on for such kind of transaction. People can transact without showing their identity and still be compliant. So the pool and the vault. The pools and the vault, the checks may use portable ZK credentials at the door. Your approvals travels with you. And this is the way that currently a few protocols trying to implement. And the last inner circle is the money that coming in. So you don't try to check the whole world. You're trying to move this compliance to a regulated middleman, whoever is in between the DeFi and its user. And usually this is a bank or a regulated stablecoin issuer. So the pattern is the less control the protocol has, after all, the further is, so the bigger is the circle that it's working with. So that's the major key. I tried to arrange this framework for myself, actually. I hope this will be useful for others too. So let's move from control theory to trials. Between 2024 and 2026, the question became who is under control. And this question was tested in court. Prosecutors tried 3 approaches, and the one they choose decided whether you win or lose. So first one, the running unlicensed and money transfer business. So this needs no control of funds, only running a service. And this is something that's actually happened. In Tornado Cash case, Roman Storm was convicted on exactly this charge. The founders of a large non-custodial mixer pleaded guilty and went to prison. So they claim that it's not custodian actually failed. So to say, not custodial running non-custodial business doesn't protect you as a person. Point number 2, money laundering. So money laundering always needs an intent. So this is harder from a jury point of view. But what happened in Netherlands to another Tornado Cash founder, he was pled guilty to fail to prevent money laundering. So this not actually for money laundering, but failing to prevent money laundering. And this is the case we currently have in Netherlands. And number 3, the sanction in the code itself. Originally, US jurisdiction sanctioned Tornado Cash itself, but later they got back the sanctions, and right now Tornado Cash smart contracts are not actually sanctioned. So in 2022, the US Treasury sanctioned that another cash smart contracts themselves. Let's stick to this point right now. And in 2 years, the US Court of Appeals canceled that. The contracts that can be changed, as the court said, are not property, and no one, even the developers, could control them. So the Treasury actually removed this sanction. So this is actually a big win for the community as a whole. So here is the paradox answer. It's the same fact, no one has a control of the code, did two opposite things. For the code, no control is a shield, so you cannot sanction the code anymore, and you cannot sanction the protocol anymore. And for people, no control is not a shield. You can still convict people who run the business around it. And so the real question is not is it decentralized, but who is in control of the protocol? And the same fact actually can set the code free and move people to jail. So regulators have a clearer option now. Put a control point inside the money itself. The global rule setter now tells countries to make stablecoin issuer keep the power to freeze and destroy tokens and to watch them, even between private wallets. The response is already here. The stablecoins built to be freeze resistant, and that's the opposite purpose actually. Money is splitting into two kinds, the freezable and not freezable. I mean, money in blockchains split into parts. And it works even for everyone who cooperates. In 2026 operations, police frozen millions of dollars so far, but the latest analysis report says that 84% of all stablecoins, after all, land somehow on illicit activity wallets. So it's a huge amount, actually. So basically, we have 4 open problems left. One, the cost of the privacy. The same tools that stop North Korean also watch ordinary users, unfortunately. And we are now often sending developers to prison for open source code. The honest answer is already being built. Prove you are allowed without prove that you are allowed to transact without giving up who you are. And ZK KYC is the way to go here. So point number 2 is that authorities and states sometimes contradict themselves. So from one point, at one point they ban privacy coins, other jurisdictions make these privacy coins alive, and there is no, let's say, well done and approved approaches to how to treat privacy coin on their own. So point number 3, the escape valve. If authorities start to push really hard, this moves activities to no control end, into offshores, into freeze-resistant money, and this makes the situation even worse and less visible to all authorities. So, and the two-level system, permissioned and not permissioned. And the main question here is, after all, who is in control? So crypto was actually built to remove the middleman, and regulation followed these middlemen anyway. Not by breaking decentralization, but by asking a better question. So we are not asking, is it decentralized anymore? We are asking who is in control. And the answer actually tells you who is responsible, where compliance lives, which code goes free, and who is actually operating this exact protocol. The projects can accept some control and will get banks and trust, and others may not do that and work on the edge of the regulation. But this is actually something that can lead people to prison as of today. So the real question is not whether the DeFi going to be regulated, but how DeFi will be regulated and who will be in charge of DeFi protocols. And authorities are actually going exactly this way. They would be chasing people who is in control of DeFi arrangements. Basically, that's all from my side. If there are any questions, I will be happy to answer.
All right. Thank you so much, Mike, for such a great presentation. I have a couple of questions from me, and there will be a couple of questions from the chats. And let me start with the first question. I would like to ask about some kind of best advice for builders and founders to avoid regulation-related problems.
You mean the DeFi builders?
Yes, of course.
Yeah. I have bad news. So most likely there will be very few possibilities to avoid regulation. And even if you will avoid regulation as a founder, most likely you will still be treated as a person in control, and this can bring you into troubles. So you can try to evade regulation. Yeah, that's true. But most likely you will not be able to make yourself out of control if you want to make money on your own protocol. Charging fees, having control keys, this all will lead authorities to understanding that you exactly is the person behind the protocol and you are in control of that protocol. And if you are in control, you're responsible for that protocol.
Mm-hmm. And let's start asking questions from the live chat. The first question says, do you know what are the misconceptions that founders usually have about decentralized equals safe from regulation?
So this, I would not say it's misconception, it's misunderstanding. So the founders are usually either business or technical guys. They are not definitely they don't have legal background, I would say, and they very rarely directly talk to regulators. So the regulators have very different mindset. They're trying to maintain the rules and maintain the situation in controllable way. When they are trying to understand DeFi, the main question is also how can we prevent something going through DeFi? And who can prevent something going through DeFi? So this led these guys chasing people in control, just because they do understand that there is no company behind DeFi, and this can be a truly decentralized arrangement. But after all, there is a person who holds a key that is capable to upgrade smart contract. If this is the case, this person is responsible for that protocol, and that's it.
Mm-hmm.
So there is no way
mm-hmm.
you can be safe from regulation. I would say that there is no way that you can be safe from authorities. This would be the better word.
That's what we have, for good or for bad, anyway. And next up, someone asks, is Uniswap really no control? What about website blocks?
So it's a very interesting case. Uniswap is US-based company, the Uniswap Labs, who actually is behind the Uniswap. So they have very good and powerful legal stuff, I would say. So I've been in touch with Uniswap directly and talking to guys from Uniswap. So they have a statement that we design protocol, we upload protocol, and we deploy protocol, and we don't hold a key that can upgrade this protocol. So this is a public good. The protocol is safe. But they use a website and they promote the website, they invest in marketing, and they're responsible for the website. So their compliance sit within the website, and they keep an eye on this compliance. But they clearly say that they're not charging fees, so they're not making money out of the protocol. They're charging fees out of the router which is linked to the website itself. So when you are swapping through the website, you pay fee to Uniswap Lab. When you are swapping directly on a smart contract and avoiding the router contract, you are basically you are not paying fee to Uniswap. And this is kind of gray area in the regulation. So just because they don't have any kind of profits going from the protocol directly, their statement that the protocol is a public good is true. So that is how they deal with all that.
And a couple of more questions and a couple of more minutes for our session. Someone asks, if protocol is open source, why dev can go to prison?
This is a hard question. The protocol is open source, but again, somebody have deployed this protocol. Somebody can hold the key of an administration contract that is capable of upgrading the smart contract. And this is all a number of criteria. So the cases are that if you are, so let's say in Netherlands, when they have been conducting trial against another cache, so the main motivation was that you have designed a tool that is obviously used for money laundering, and you have not, and you didn't do anything to prevent that usage. So even if you design a shovel, but you make it really sharp so that people tend to buy this shovel for killing other people, this doesn't mean that this shovel is safe and the only way that you can use it is actually digging potato in your backyard. So this is a very gray area. It doesn't mean I'm okay with that and I agree with that, but this is how it works. Even if you designed the protocol and it's open source, you can still go to jail. And it's really hard to understand the edge when you are still responsible for that protocol and when you are not really responsible for that protocol. If you have designed the protocol and all you did is actually commit to GitHub, then probably you're not responsible for that protocol. But if you have designed a protocol, created smart contracts, deployed all that into Ethereum blockchain, most likely you are.
And the same person asks, if no one controls the smart contract, who regulator punishes then?
If no one is in control of the smart contract and no one holds authority to upgrade the smart contracts, like let's say into another cache case, then the smart contracts itself, so then there is no person who is actually in control. But if you build a service around this smart contract, or you consult other people how to use this smart contract for particular cases linked to money laundering, then you're in trouble.
And one last question. It says, which country now most strict for DeFi teams, UK or US?
UK.
All right.
That's true.
And clear.
FCA has so they did a great job as an authority, honestly speaking, and they hired a lot of staff here in United Kingdom, and they are trying to chase all the people who are actually. So they're trying to, let's say, to do either two things, or bring DeFi arrangement inside the jurisdiction and incorporate it here, or make it not work with locals in United Kingdom, so take it outside of the borders. So, but regulation in UK is way more strict compared to US nowadays.
All right. And I see that this is it, right on time. The last question covered. Thank you so much, Mike, for keeping us up to date about the DeFi situation and about what's happening right now in 2026 and about the regulatory trends. That was really useful, really up to date. Really happy to see you here on the stage and looking forward to see you again and again.
Yeah, thanks so much.
And after a short transition, just 10, 20, 30 seconds, we'll be back with the next guest and we'll be speaking about privacy and security. All right, so here we are back with the agenda, and this will be our third talk of our second day of the Blockchain Community Day conference, and we'll be having 3 more talks after that. And I'm very happy to invite our today's guest speaker, Ike Andreasyan, who is the senior security researcher at Hexens, and our today's topic is privacy preserving AI. Hi, Ike, how are you?
Really great, thanks. How about you?
Yeah, me too. Thank you so much for joining. And yeah, while we are updating, bringing your presentation to the stage, could you please just tell us a couple of words about yourself and about your background and who you are?
As I said, my name is Ike Andreasyan. I work at Hexens as a security researcher, concentrated on Web3, Web2 security, also cryptography and AI.
All right. And yeah, that sounds amazing. I can see that your deck is on the screen. And yeah, you're good to start. Good luck.
Thanks. So today I will talk about privacy issues and attacks in AI systems and how different cryptographic techniques can be used to mitigate them. Modern AI systems are no longer isolated models running on static datasets. Today, AI operates as a multi-stage pipeline. At every stage of the pipeline, data is transformed into different representations such as gradients, embeddings, activations. These representations create privacy leakage surfaces. And so the challenge is no longer just for the data, but how do we secure the privacy of the entire AI pipeline? AI system consists of multiple interconnected components. The core pipeline includes data collection, model training, inference, and output generation. Also, an additional retrieval pipeline is added through RAG architectures. The documents are transformed into embeddings stored in vector databases. The algorithms of machine learning and deep learning were originally designed without a defense mechanism against malicious threats in mind. And it was believed that black box deployment was a sufficient security boundary. So by wrapping a model in an API that only returns the prediction or confidence score, the training data was thought to be secure. But there are adversarial machine learning attacks on those systems. So before discussing the attacks, it is useful to define what privacy means in AI systems. Different parts of the system require different protection guarantees. For instance, training data privacy guarantees that the malicious actor will not be reverse engineer the training data. Input privacy guarantees that the user input data cannot be observed by other parties, including the model creator. Output privacy guarantees that the output of a model is not visible by anyone except the user doing the inference. Model privacy guarantees that the model cannot be stolen by a malicious party. And together, all this define the main privacy dimensions that AI systems must address. After understanding the main privacy problems in AI, we can look at how these leakages can occur and how attackers exploit them. For example, the memorization of training can cause privacy issues. Also, there are membership inference attacks, model inversion attacks, or model extraction attacks that also can leak privacy data. So let's look at each of them. Memorization occurs when a machine learning model stores specific examples from its training data inside parameters instead of learning the general patterns. This becomes a privacy risk because the model can later reproduce or reveal parts of those exact training examples during the inference. In sensitive domains, this can lead to leakage of private information that never was intended to be exposed. Several factors increase the likelihood of memorization in machine learning models. For example, duplications in training data are most likely to be memorized. Larger over-parameterized models have more ability to store specific examples rather than just generalize the patterns. Also, longer training can lead to overfitting. In membership inference attack, the attacker tries to determine whether the specific record was part of the model's training dataset. Attackers create shadow models with known training data to learn to differentiate pattern between member and non-member samples. And this simple yes or no information can violate the privacy. And memorization is one of the main problems that can cause to successful membership inference attacks. The other attack is member model inversion attack. Here, attackers submit carefully crafted queries to the ML model, analyze prediction outputs, and through the repeated iterations, they are trying to reconstruct the sensitive features from the training data. At its core, model inversion is an optimization problem. The attacker treats the model as a mathematical function and attempts to find an input that maximizes the model's output for a specific class. It's like the opposite of membership inference attack, and here attacker asks what people in your dataset look like. And you can see in the picture from the right is the actual trained data, and from the left side is the recovered data. The next attack is model extraction attack, where adversaries repeatedly query a model API to learn how a model behaves. Over the time, they can approximate the original model, effectively stealing the intellectual property and sometimes recovering the memorized data. This is particularly relevant for public APIs. As we know, at the heart of RAG is a vector database. During retrieval, the system searches for vectors that are close to the query embedding. One important privacy risk is embedding inversion attack. Although embeddings are numerical representations, they can still preserve semantic information from the original data. In an embedding inversion attack, the adversary attempts to reconstruct the original input directly from the embedding vectors. For instance, we can see here that the user tries to embed I love fishing, how about you text. And the attacker, when he steals the embedding model, he creates the inversion model and recovers the text, I love fishing, do you? So you can see that the recovered text is not exactly the same, but meanings are close to each other. So now let's look how different defense mechanisms works. For instance, there are training time defenses. One major approach is differential privacy. Another approach is data sanitization, which focuses on removing or anonymizing sensitive information before the training begins. Finally, regularization techniques such as dropout, early stopping, or weight decay can help to reduce the overfitting, which also lowers the memorization and privacy leakage risks. Other common defense mechanism is inference time defense. One of them is query limiting. By restricting repeated queries, systems can reduce the risk of extraction and inference attacks. Output filtering also helps to detect and remove the sensitive information from generated responses before they are returned to the users. Beyond training and inference protections, privacy can also be improved at the architectural level. Federated learning is a distributed training approach where user data remains on local devices and only local model updates are shared with the central system. Another important technique is the trusted execution environments, which provide hardware-level isolation for sensitive computations. So let's look at each of the techniques more deeply. Differential privacy is one of the most common approaches for protecting sensitive data. Its goal is not to completely hide the dataset, but to mathematically limit how much information any single individual can contribute to the final model. The core intuition is that if we slightly change the dataset, by example, for removing a single person's record or somehow change them, how the output of the algorithm will behave. In other words, the participant of single individual should not have a noticeable impact on the system's behavior. So the idea is illustrated in the figure. We have two datasets, D and D prime, and they are differing with one entry. And we have some randomized mechanism M, which is applied on both datasets. And from the picture, we can see that the probability distributions of MD and MD prime are almost the same. And because the outputs are statistically similar, an attacker observing the system cannot confidently determine from which dataset the answer was returned. And we can see here an epsilon parameter, which called privacy budget. And if the epsilon is small, the privacy is stronger preserved. But the stronger privacy we can cause to bad effects on the actual inference and accuracy. So differential privacy works by injecting some calibrated statistical noise into computations or training process on output or even on inputs. The noise hides the individual contribution while still preserving the overall statistical utility of the data. Depending on dataset type, gradient computation, model architecture, the privacy guarantee differs offered by each of the noise addition. And you can experiment with differential privacy frameworks like Opacus, Tensor Privacy, and maybe some others. Another privacy-preserving technique is fully homomorphic encryption. Homomorphic encryption itself is a cryptographic technique that allows computation directly on encrypted data. In traditional encrypted systems, data must first be decrypted before any computation can be performed. Homomorphic encryption changes this model. For example, a user can encrypt data locally, send only ciphertext to an external server, and the server can still perform computations without ever decrypting the data itself. After the computation complete, the encrypted result is returned to the user, who decrypts the final output locally. And there are several homomorphic encryption systems that are based on the computations they support. For instance, partially homomorphic encryption support only one type of operation. Either it can be addition or multiplication. Leveled homomorphic encryption supports both addition and multiplication with leveled computation circuits without requiring bootstrapping. But after some level of computation, the decryption fails. To overcome this, there is fully homomorphic encryption, which supports arbitrary computation on encrypted data. This means that complex programs, neural networks, even AI inference pipelines can be executed entirely in encrypted form. Also, there is another categorization of FHE. One of them is exact FHE, where every operation is performed in a precise way. Then the result after the decryption is the same as would you get if computed directly on plain text data. Schemes like BFV, BGV, or TFHE fall into this category. The other one is approximate FHE, which somehow relaxes the exact precision. Instead of exact integers, it works with approximated real numbers, which allows to perform operations on floating point data. This is especially useful for machine learning and neural networks. The CKK scheme is one of most common examples. And a key challenge in all FHE schemes is the noise growth. Every computation adds noise to ciphertext, and if that noise becomes too large, the data becomes unreadable. And there is a technique which is called bootstrapping, which refreshes the ciphertext by homomorphically decrypting and re-encrypting it, reducing the noise back to a usable level without exposing the plain text. So before discussing the private inference, let's look at the basics of large language models. LLMs are based on transformer architecture. The model receives the input prompt, converts it into embeddings, and processes them through multiple layers. Inside these layers, model uses self-attention, matrix multiplication, non-linear activation functions, and some probability transformations to learn the relationship between the tokens. One of the most important components is attention mechanism, where the model computes query, key, and value representation to determine which parts of the input are most relevant to each token. After the attention scores are computed, the softmax function converts these scores into probabilities. And this representation then passes through additional layers, producing probability distributions over possible next tokens for text generation. And from privacy perspective, this LLM architecture introduces a major challenge. During the inference, user prompts, intermediate activations, and attention computations are normally processed in plain text on the server. And as you can see in the diagram, to overcome this, we can use FHE, where we can encrypt the prompt, do a private LLM inference, and then the server returns an encrypted answer where the user can decrypt and read the result. For private LLM inference, mostly it is chosen the CKKS scheme, which is not exact, which is approximate FHE scheme. To perform private LLM inference, standard LLM components must be translated into CKKS-based operations. One of them is ciphertext to plaintext matrix multiplication. This occurs when multiplying the encrypted data by unencrypted model weights, such query key and value projections and neural networks. This operation is computationally cheaper and adds less noise. And another one is ciphertext to ciphertext multiplication. This occurs when multiplying two encrypted matrices together, such as when calculating the attention scores from encrypted queries and keys. And also, it must handle nonlinear blocks. For instance, the nonlinear functions like softmax activations cannot be computed natively in CKKS. They are approximated either some polynomials or replaced with simpler polynomial alternatives. And the encrypted operations can easily exceed the noise budget of CKKS, and that's why it is required to apply the bootstrapping technique to reduce the noise and restore back to the normal noise budget. Also, there is a real-world usage of FHE with machine learning. iPhones has a feature called Enhanced Visual Search for Photos, which allows a user to encrypted search their photo for specific locations. The client encrypts a vector embedding of the picture, sends the picture to the server, and the server performs homomorphic computation to compute the nearest neighbor and send the encrypted result back to the device, and device decrypts it. Also, they use differential privacy with strong privacy parameters. And also they use some anonymization techniques to hide the IP address of the device. Okay, the next privacy preserving technique is federated learning. In classical machine learning, all training data is collected and stored in a central location. The model is trained on this centralized dataset. Federated learning takes a different approach. Each device or client trains the local model on its own data. Only local model updates are sent back to the central server, which they are aggregated into a global model. So the key difference is classical machine learning centralizes the data, while federated learning keeps the data decentralized. This slide illustrates its overall workflow of federated learning. It starts with a central server that initializes a global machine learning model. This model then distributed to the chosen clients. Each client received the current version of the model, trains it locally using its own private dataset, and it is important that the raw data never leaves the device. After local training is completed, each client sends its update back to the central server. And the server does not use the data directly. Instead, it aggregates all the received updates with an algorithm like federated averaging. And after averaging, it sends back to the client devices. And this whole process repeats over multiple communication rounds. You can experiment with federated learning using the NVIDIA Flare or TensorFlow or Flower framework. Here in this computation can arise some privacy issues or trust issues. For instance, during the local training phase, client might introduce malicious models to disrupt the system. Or at the global aggregation stage, the trust issue also can arise. For instance, the aggregator can add malicious malicious updates instead of using the honest client's updates. And there is a zkFL solution that overcomes this issue. We can look how that works. During each round, the client trains their models locally. Each client encrypts their weights using a Pedersen algorithm. Then the client signs the encrypted updates. Then it sends the tuple of local model update, encrypted model update, and the signature to the aggregator. And the aggregator aggregates the received local model updates, generates the global model update. Then it computes the aggregated value of the encrypted global model update and signs it. After it generates a zk-SNARK proof of the computation and the encryption was done using only client's weights. Then the aggregator transferred the global model update and its encryptions to the clients and broadcast the proof to the blockchain. And if the proof is correct, the hash value of the encryption is written to the blockchain. And when the next round starts, the client reads the blockchain to check if the hash is appended on chain. Another approach of federated learning is decentralized federated learning. Although we can see that federated learning is decentralized training platform, but there is a problem that it has a centralized coordinator. Decentralized federated learning removes the need of that coordinator. Instead, the clients participate in P2P network where each device performs local training and directly exchange the model updates with each other. In some designs, it is used blockchain as a coordination layer, and smart contracts can be used to manage the training logic, ensure that only valid updates are included in learning process. But in terms of practical usage, decentralized federated learning based on blockchain are still experimental. And in general, the stronger privacy protections often reduce the model accuracy or system efficiency. And as it was said, for instance, adding noise through differential privacy can protect the sensitive data, but it may also decrease the model performance. Techniques such as FHE can provide strong guarantees, but they are still expensive in terms of latency and computation. And because of this, privacy-preserving AI is fundamentally an engineering balance between utility, performance, cost, and privacy guarantees. And there is no single mechanism that can completely solve the problem. Thank you. Questions?
All right. Thank you so much, Ike, for this amazing presentation. Let me just quickly go through the questions. And yeah, before I start asking questions from the live chats, let me just ask a simple question from myself. And yeah, you know, I'm not that technical person, but still for a normal person using some kind of AI tools, what is the number one thing that can leak? Is it my prompt or my files or the AI trading data or what else?
So, for instance, if you are installing some skills, they can be some malicious skills which can steal the environment variables, some private keys. So yeah.
All right. And a question from the live chat. It says how hackers can steal model from API.
Yeah. Can I get back to the slide? I can show.
Sure.
Here you can see that the adversary tries to do as many queries as he can, and he collects many key value examples where the key is the input of the model and value is the output of the machine learning model. And having this tuple, he can try to create its own local model, training with that collected data, and he can try to mimic the original model.
I believe that answered the question. So whoever asked it, feel free to ask any more details about it. And the next question says, what will be the best easy protection for startups? Rate limit, filter output?
Yeah.
And one more question, what is the first defense they should add along with rate limits, output filtering, or something else?
So as it was said, for instance, use the differential privacy techniques, add some noise on training data, but it's like an experimental one. You cannot say which epsilon value is correct. You must try some different values and understand which is suitable for you. Also, yeah, you should add the rate limitings, output filtering. You can also use FHE or multi-party computations too.
And a couple of more questions. Differential privacy equals add noise, right? Does it kill quality?
So it is a trade-off. You must find the correct balance between the noise and accuracy. When I showed the iPhone example, they also used the differential privacy there.
All right. And I think that was the last question. Thank you so much, Ike, for this wonderful technical presentation. Yeah, I think so far this is the most technical thing we had throughout the past 2 days, but still more to come. Really happy to host you and feature here on our conference, and really happy to see you again on our stage in the future.
Thank you too.
And yeah, after a very short 1-minute transition, we'll be back with our next speaker. So please stay tuned, and in 1 minute, we'll be on the stage. All right, so here we go again. And this time we are going further with our agenda. And this time I am inviting our next speaker, Andrei, who will be speaking about the state of confidential Web3. And hi, Andrei, how are you?
Hi there. Pretty good. Do you hear me well, see me well? Everything's okay?
Yes, sir. Yes, everything is
Perfect.
fine. We can see you well, we can hear you well, and we are very happy to always invite everything, speak about everything NEAR related. Actually, I mean, we are good old friends with a lot of people from the NEAR ecosystem and around, and yeah, that is very enjoyable to see more and more content about it. And yeah, without further ado, I would like to ask you just shortly introduce yourself and tell us a couple of words about yourself and about your background, and after that, it will be good to start with the presentation.
Sure. So I'm on the product side of things. I'm Andrei Kirkunen, and I'm on the product side of NEAR Intense. I joined NEAR recently, relatively recently. It would be like around 8 months now. Before that, I worked for 1inch Network, Gnosis Safe, and P2P.org, a few very notable, nice companies. Now with NEAR, working on the B2B side, integrations, partnerships, and confidential intents is something that we are working now very closely. So in this presentation, I would like to show the state, like how does the ecosystem of confidential Web3 look like? Why is it even needed? And show you the logic, how we built our solution, why we built it like that, and why we think it's if not better, but at least complementary to the existing solutions, and how we see the future of these confidential Web3 use cases.
Mm-hmm. And yeah, amazing. I can see that the deck is on the screen and the stage is yours. Good luck.
Okay, perfect. All right, so first of all, I would like to make a few disclaimers about what we are not going to cover in the presentation. So since I'm a product person, I will not go into the cryptography challenges, zero knowledge proofs, deep technical comparison. So I will provide high level technical comparison to understand how are the solutions different from each other, but we will not go too deep into that. And another thing that I would like to not cover in this presentation is the ethical aspects. You will see a few examples of cases that are that have ethical aspects, but we will not touch them in the presentation, in this speech. So what we're going to cover. So what is confidential Web3? Why it became a thing in 2025? What are the major players and how are these players different from each other? What are the volumes there? And most importantly, when do we get the institutional capital into all that? And what actually separates us from this very moment? So I would like to start with the classic binary opposition in blockchain industry, because we used to think for many years that there is an opposition between the centralized exchanges and decentralized exchanges, and the opposition is as follows. So basically, a CEX trading is when the trading is custodial, so when the exchange actually holds the keys. When it's permissioned, so you have to pass the KYC and KYB probably if you're a business to actually start working on the exchange. It is centralized, meaning that the logic is mostly server-side and there's no real blockchain settlement happening there. And it's private, and because the transactions are not exposed. You do see the order book, you see what's happening. Sometimes you see the order book, sometimes you don't. But generally, the transactions are not traceable, so you cannot really track who is actually doing trades there. While the DEX trading is non-custodial because the traders hold the keys. It's permissionless, so you don't have to pass KYC in most cases. Of course, there are cases that you have to, but mostly you don't. It's decentralized, meaning that there is a real blockchain settlement happening, and there's a fair amount of on-chain logic and smart contracts involved, but it's public. So all the transactions are visible on the Block Explorer, and various researchers can actually track who is doing these transactions, and sometimes de-anonymize the wallets. It's not that simple sometimes it is, but still all the transactions are public. So this binary opposition was a given, effectively. But what is confidential Web3? It's basically when you take all the best pieces of DEX trading and you put the privacy component there, so you don't expose all the transactions. And why is it needed at all? Who actually needs that? For now, I have to make a disclaimer that these things are a bit theoretical because we don't really have, I will talk about that in the last slides of the presentation. Thing is that it's not really yet widely adopted by any of the institutional players. And we are still hoping for this moment to come. But what we see as use cases, and what we, it's not just us ideating about that, it's based on the bunch of conversations, podcasts, basically customer development sessions, interviews. So there is some substance there, but still we don't yet have the numbers. But what we're talking about here is the professional portfolio management, preserving market insights, and generally like buying and selling assets without the unnecessary unnecessary attention attracted to these operations. So this has become possible, and this has become a thing. Okay, first of all, like we will touch this in later stages, the privacy preserving solutions on the blockchain date back to the very early days, like more than 10 years from now. But all of that became a thing and sort of like went out of the niche in 2025 when a few regulational documents, we will not touch them in depth because this is a separate big topic, regulational landscape in the US. But in a nutshell, regulational landscape has become sort of favorable of privacy preserving solutions in the US mostly. So this comes from there. There's no specific like law or whatever that says private blockchains are good. But the interpretation of these regulations have created a demand and like attention of the investors and general public in crypto Twitter and outside of crypto Twitter to this matter. So this is just an example. It's not very like you have to zoom if you want to take a look. But this is a funny slide that our founder, I stole it from our founder that posted it today. That Charles Hoskinson from Cardano, he actually has done some dumping of Cardano tokens, and there are researchers that actually are investigating this matter now. So this is a reputational damage, and we don't really want. So basically, Charles, I'm pretty sure that if privacy solutions, robust privacy solutions existed back then, he would never dump any ADA tokens publicly. So he would probably use near intents for this, and we really hope he will do that next time. It's not illegal. It might be unethical. That's what I meant by the. We will not touch the ethical aspects and discuss this. Is it really? Can people actually do that? But there is a demand, and there are use cases like that. So you don't really want independent researchers to dig into your transaction history. Solutions. So there's a large variety of different solutions for the confidential transactions. The most obvious one is a confidential chain. So there is a segment of default privacy chains. So by the way, all the terminology that is going to be used here is just my humble attempt to systemize all that. Default privacy chains means that all the transactions are private there, and there are OG players there, such as Monero and Firo or Firo. I'm not sure what's the correct way to pronounce that. Formerly Zcoin, and there's a new blockchain coming, which is called Tari. It's also live on mainnet. So everything is private in these chains. There are various types of technology happening there, like. But the main problem is that at least Monero is UTXO based, and actually none of these chains are properly programmable. So you cannot create smart contracts, trading primitives there. You cannot replace Ethereum by these chains. Another problem is that it's not per se illegal, so there's no such a law or whatever, like you cannot use Monero, but you can draw unnecessary and the attention from the law enforcement if you do that, and there's a very limited capability of integrating such a chain into any of the cross-chain or chain abstracted solutions because of these concerns. You don't want to draw unnecessary attention. So there's also a class of optional privacy chains. So basically, you have to opt in to make specific transactions private. So Zcash and Dash are in the category of the OG. This is my own classification here. So the main differentiator here is that these chains are non-programmable. And by the way, so not all transactions are private, and I actually checked recently what share of the volume on Dash is shielded, and it's like very, very modest. So generally, people are too lazy to use this, to be fair. But the optional nature of this privacy creates a better legal appreciation of these chains, and so you can actually integrate them. So we integrated both Dash and Zcash into near intents. Second generation is TE-based programmable chains such as Oasis and Secret Network. They have their own niche adoption. So Oasis is more focused on some institutional cases. Secret Network is more of a, let's say, Cosmos-based network for general purpose. And finally, there's a third generation of ZK programmable chains with optional confidentiality, which is Alio and Aztec. Aztec is a EVM rollup. Alio is a independent L1. So all of these guys, the good news is that they are programmable, at least the modern ones. But there is still an adoption difficulty. Like basically, you have to, especially with L1s, you have to care about the wallets, and you have to care about the liquidity fragmentation, and yeah, basically using a chain with limited TEL is always a challenge because you have very limited options. Like it's pretty obvious. But what if we make it not a programmable privacy chain, but what if we create a product on existing chains? So another disclaimer: these diagrams are overly simplified, so they are like primitivized, if you will. But just for the sake of time and understandability. So multi-hop private DEXs is one of the products that preserve privacy. So these guys are usually helping you transfer funds from chain A to chain B. So from Solana to Ethereum, for example. And in between the asset A and asset B, there's a combination of CEXs and DEXs sometimes. Sometimes just CEXs, sometimes just DEXs. But it's always happening like it's basically a solver doing the settlement for you, and basically due to usage of sexes, the trace is sort of hidden. Notable examples is Houdini Swap, RocketX. I might have forgotten something. Sorry for that. If you know more, please leave in the comments or in the questions. I might have missed something. Houdini Swap and RocketX. The issues are actually very high cost because the actual cost of transaction is high because you have to pay fees on the CEXs. So we have done some research. The dollar diff between money in and money out varies from 2 to 10%, even on large amounts, even like thousands and tens of thousands of dollars. So that's huge. That's very expensive. Another problem is matching USD values, which I will touch later, and bad UX because you have to copy addresses, and so it's not cool. Shielded private access, again, my terminology, and this is very overly simplified, some shielded contract because the solutions are very different. Also, Railgun is not a DEX. It's more of like a solution to build on top of. Privacy cache and encrypt trade have proprietary front ends. So you still, anyway, you basically, the thing is you shield, you trade, and then you unshield. So that's how it works. The good part is it's cheaper. So it's still there. The cost is pretty high. We also did these checks ourselves. So the fees are still high. And also they're focused on a single ecosystem, single chains or a single ecosystem. I'm talking about EVM for Railgun, for example. Also matching USD values do not go away anywhere from here. And also bad UX. like, I'm sorry for that, but like, just give it a try and you will see what I mean. Near intense, so time to explain, like, given all that, so absorbing all this information about the existing privacy solutions, we have launched our own. We have done a few series of soft launches, so it's still not fully fledged. Like we still like it's not has full feature parity between confidential and non-confidential near. But like what lessons have we learned from the existing solutions? So again, this diagram here is like extremely simple, but the thing is, like, basically there's a private shard of near in between asset A and asset B. The asset A and asset B can be, unlike the previous solution, they can be on multiple chains. This can be Bitcoin, the asset A, the asset B can be Cardano. Charles Hoskinson can probably use that as well. So the upsides of this thing, of this setup, I will touch the architecture on later slides, but it's chain abstracted. So like just explain. So it can be 35 chains. Same stack as public near, so there's no complicated ZK technology involved here. You don't have to generate ZK proofs or like do ring signatures or do whatever that is usually used in some more OG networks. And finally, the USD value is not necessarily matched. And let's finally touch the USD value problem that I mentioned a few times already. So if you zoom in, you will see that if you do a foreign-to-foreign confidential swap, basically like on Houdini swap on the Orchid-X or wherever, where you use like source chain and destination chain, so you basically breach the same amount of dollars, and you breach in and breach out. It can be slightly different because of slippage tolerance, and because of slippage, and because of like the market rate fluctuation can be slightly more, can be slightly less, usually slightly less. But still, if someone like a researcher that goes after Charles Hoskinson, so they install the event listeners on the bridge that bridges the money in and bridges the money out, they can quite easily track what's happening there. Well, it requires some skill, of course, like not everyone can do that, but it is still possible, and it's possible on any of the solution that does immediate foreign-to-foreign swaps, just does not depend on technology. So again, I will, if you want to see the details, I suggest you zoom in. Otherwise, I'm sorry for the small letters here. But one of the ways, if you still want to do the foreign-to-foreign swap, like Bitcoin to Ethereum, you would want to do a split, uneven split, so something that is randomized, and the random delay. So, and each part, it can be more than 2, by the way, it can be 3, 4, 5, like whatever, potentially unlimited. And the withdrawal is going to be happening with some time delays. So this way, it makes it much harder to track, but it's still possible. And the ultimate solution for this is to basically use near intense as an embedded account, because near intense, you can use it as a trading interface. We're still lacking some of the nicer professional trading primitives, but you can do spot trading there. You will be soon able to do perp trading on the confidential shard. For now, it's only available on the private shard, public shard, sorry. But the thing is, like, you deposit there, you do stuff, and you might hold funds there for some time. You can rebalance them, trade, probably deposit to some yield protocols, earn some money there, and then occasionally withdraw to one of the 35 supported networks. Then if there's like not matching amount, several weeks passed since the deposit, there's just no way to track the source. Now, chain abstraction. I mentioned some of these things already. I will not really spend too much time on that. But the thing is that it's not only like a bridging solution. You can also control balances on near intents from any of the foreign wallets. You can do this from MetaMask, Phantom, you name it, even from Stellar wallets. And you can use the chain signature primitives, chain signatures primitive to sign transactions on foreign chains from near intents. So that's the power of the interoperability. And Zcash, Dash, and Alio are already supported, and more privacy chains will come. So we see ourselves as not a competitor to these, but rather like a one ring to rule it all. Anyway, so the chain that stands like basically that enables the interoperability between all of these networks. That's our positioning here. So supply, the volumes, I was actually promising you the volumes. In short, like you don't even have to zoom. The volumes are pretty modest. We're talking about tens of millions in all of these ecosystems at best. So the second slide is about near intents. So if you really zoom in, you will see that we're talking about like 20 something million. But okay, like we are a few months old, so confidential intents are a few months old. So, and we are making it, we're taking it slow. We're just getting started. And yeah, so it's very far from, not even from traditional finance with trillions, but even from the public blockchains yet. But like basically when moon. So what separates us from institutional adoption and bringing in billions and tens of billions there? So I have to make yet another disclaimer that this is not an official position of Near Foundation. Not sure why did I include that, but for some reason I thought that I'm taking too much responsibility. But still, my personal opinion that we need more trading primitives, limit orders, stop orders, TWOPs, you name it, unlimited asset access. So basically long tail assets that are available on any DEX, on any chain, should be available there. So that differentiates us from a permissioned CEXs, because why would they trade at all? Because CEX, like simple Binance, can offer them privacy and they can still trade pretty much anything, but integrating long tail assets gives them access to assets that are not whitelisted. Simple integration is already in place, so this is our core value. So we are integrated with a simple API. Compliance setup, something that I haven't touched, but we are quite openly say that near intents and confidential intents are not designed for money laundering, drug trade, weapon trade, you name it, because we collaborate with law enforcement, and this is not a back door. This is more of a front door. So we preserve trading secrets and business secrets, not secrets from law enforcement, and robust security, which is also our core principle. So we are very, very conservative in this sense. So that's why we're moving relatively slowly. We are not making like sharp moves. Prefer to triple check everything. Yeah, that's pretty much it. I left 5 minutes deliberately for the questions. And yeah, thanks everyone. There's my Telegram. If anyone wants to chat, please, anytime.
Yes, thank you so much, Andrei. Really informative and really up to date for 2026, as if the mid-year time period. And we have a bunch of questions in the live chats, and I'll be bringing that one by one. But before that, before that, let me just quickly check the comments section. One moment, please. Yeah, before that, I'd like to ask one question from myself. Could you please just start telling me actually what has changed back then in 2025 so that this topic has becomes much harder than it was before? I mean, any certain market conditions or some sort of news or actions by institutions or anything else?
I didn't manage to find like a specific speech. There was a speech, I think it was in Congress, but we're talking about interpretation of the regulations. So it's more of a vibe thing. Like if I can use this term towards the very respected people in the Congress, but it's more of a vibe thing. Like basically there are regulations, but none of these regulations explicitly whitelist privacy chains. So there were new bills coming out that actually moved the responsibility to the front ends. First of all of we're talking about is all infrastructure. So the front end and the end user interface is something to blame. This is one thing, which actually greenlights the development of the infrastructure projects. and shift the responsibility towards the front ends. This is one thing. Second thing is general appreciation of the privacy-preserving solutions generally, not in the blockchain, in the financial industry, but more of like private AI that was touched already today, private medical data and stuff like that. So basically, private transactions fall under this definition of protecting privacy. So taking these two and also interpretation from some respected people. So players in the market actually made the conclusion that this is the time to act.
All right. Yeah. And now let's dive deeper into the questions. One of my colleagues is asking, is near intense a centralized solution or on-chain one?
It's an on-chain solution. So it's very important to say that if you ever use near.com, for example, like a proprietary front end, and you deposit funds there, it might seem like this is like a CEX solution, because like you see the balances in bitcoins and whatever, and you might have an impression that this is custodied by near intense, but no, there's a derivation path, and what the signer wallet that you use, for example, MetaMask, with some mnemonic imported to this wallet, it creates a derived account on Near that only controls all of these balances, and your basically signer wallet is the only wallet that can move funds. So we cannot move funds on people's behalf.
All right. And I see a lot of comments, a lot of questions with the context of Monero for some reason. Yes. And let's start one by one. What's the biggest downside of default privacy chains like Monero style for broader adoption?
Again, I was actually, it's an interesting question, because I was looking today when I was preparing like in detail for this conference, I was looking for any like lawsuits on or anything like that actually like explicitly prohibits the Monero usage. So there's none, to my knowledge. Maybe I'm wrong. Maybe people can find it. If you found any, please share it with me in Telegram. I would be really curious to look at that. But there is no explicit prohibition of using Monero or like default privacy chains. But generally, it's perceived by the regulators, as far as I can tell, that if everything is anonymous and there's no like way for law enforcement to find out who is there, and it's not even optional. So this ecosystem is considered designed in a way that can be used by criminals, and because otherwise, like if you leave the front door, back door, or whatever, like for the law enforcement, in this case scenario, you might say, okay, I'm protecting business secrets, like we tell, and that's the truth. Like that's exactly our positioning. But if everything is encrypted, protected by ring signatures, like fake UTXOs and stuff like that, so that is considered malicious. Why? I don't know. We probably have to ask the lawmakers in the US.
All right, and let's cover one more question, since all the rest of the questions are pretty much in the same context about Monero style things. And this says, what is the best way to make privacy swaps cheaper? Fees too high now.
The best way is to, not to shield near intense specifically, but if you onboard funds to a privacy sort of segment of the chain, if you stay within this privacy segment of the chain, whatever it is, like in our case, it's private shard, confidential shard of Near. So if you move the funds, if you trade the exchange assets inside this confidential part, so to say, then it's as cheap as it can get. So you don't pay for bridging fees, CX fees, intermediary fees, you name it. So you just trade, and it's virtually free of charge, very, very cheap.
All right, and yeah, this is it for the current session. Thank you so much, Andrei, for bringing so many up-to-date information, and that was really useful and really interesting. And looking forward to see you again on our stage in the future. Thank you so much.
Absolutely. Thank you. Bye-bye.
And after 1 minute, after a short transition, we will be speaking about the topic of blockchain harness. So please stay tuned. We will be back in a minute. All right, so here we are back again on the stage, and this is our fifth talk of the second day of the Blockchain Community Day conference. And we are happy to invite our good old friend, Mitya Grashevsky, who is a permanent speaker and guest on our webinar.
Hey there, how are you?
Yeah, I'm good. Thank you for being with us today, and thank you for the topic you proposed. Really interesting one, blockchain harness. And yeah, before we start the presentation itself, I just would like to ask you to say a couple of words about yourself, about your background, and what you're building and working on.
Sure. Well, I've been here before, so I'm building Akinaki chain, the fastest blockchain possible, as we call it. We spoke about that, I think, a couple of years ago, maybe, about the consensus underpowers Akinaki. So since then, we kind of launched the network, mainnet. It's more than half a year already live. And of course, like I always thought that agents will happen. I just didn't think it will happen that fast. So last 3 months was a little bit crazy because of that, because like I believe that it's just a reality that if you don't, I think any application that you can think about in 1 year, if it will not include AI in one way or another, it will be just dead. Like our, I think, connection to the world, the way we connect to the world changed completely. Because beforehand we used technology, we used interfaces, like applications that helps us to kind of do stuff. Now all of that layer has changed, right? And yeah, of course, it's not perfect. It's not like you can say that it's not good to do many things yet, but it will be there. We understand it will be there. And by the way, that has nothing to do with AGI. That is not going to happen anytime soon. That is not going to happen on LLMs we use today, but it doesn't matter because like it's good enough. It's good enough for a lot of things. And I think like maybe for 80% of things already there. So like because of that, I started to like think about how we can accelerate, because like I always thought that like agentic AI flow will have some sort of economy, and that the blockchain is best positioned to kind of be that economical layer. But and I always thought also that Akinaki is the best blockchain to do this just because of how fast and scalable it is. But again, I didn't think it will happen that fast. So like the last 3 months, we were very busy with kind of realizing this vision of like, okay, so now we have the agents, or at least we kind of have some kind of agents. I mean, we'll talk about that. How can we kind of plug it into the blockchain, and what does make sense and what doesn't make sense? And I think my today's presentation is about that.
All right, yeah, and I see in the comments that we have a lot of fans of Mitya. Everyone is calling
Hey
it the
guys.
legends. Really happy to interact with the audience this way. And yeah, I think that is great. Thank you for the intro, and the stage is yours. If you have any sharing material or presenting material, let's bring it up.
Let me share. How can I do that? My computer. What? Wait. How I'm sharing here?
So there is the monitor, the screen icon.
Oh, share screen. Yes. Okay.
Yes.
All right. Maybe this. Okay. Can we see that?
Yep, it's here.
Okay, great. All right, so I built a little presentation, and first of all, it's on GitHub. You can go and check it yourself. It's gosh.ai. There was no better name available for Gosh. And I wanted it to be a separate repository because it's not really kind of blockchain or connected directly to blockchain. So first thing we need to talk about is like how do we connect? So what is the world of AI that we have today? Like how agents are organized today? Now, what we have is an MCP, basically. We have like a model, and then we have an MCP. That's more or less what's stick at the moment, right? But this surface doesn't give us what we want, because when we talk about on-chain kind of agents or agents that acts on-chain, so yes, of course, you can take chain and you can convert it into some kind of like RCP, MCP kind of connector. But then, okay, so that's what you basically provide information about the chain to the agent. That's all you did. And thus, of course, you can give them a protocol to interact, like to create a wallet, to transact on chain. Fine, I mean, everyone will do this. But does it really goes inside the agentic flow? No, it's okay. It's agents using some wallets. It can use this wallet. It can use another wallet. It can use fiat money. It can use cryptocurrency. I mean, of course, it's quite trivial. That doesn't empower the agentic flow. That doesn't really connect. I think it's like an outside thing. So we needed first, and you will understand why. I mean, we needed something where you can create a bunch of agents and you can share them inside the blockchain. You can share them on chain. How are you going to do that? Like, you just think, this is what we want to do. How are we doing this? Right now, there is I don't know, mechanism to do this. Like, what I want to describe, we call it a swarm. Why we call it a swarm? Swarm is, of course, a loaded like name, and we used it before for many things. But because agent, like today we have agents, right? We have harnesses, and people using these terms and sometimes interchangeably. But what we need is somehow in between, because the harness is a kind of a runtime of the agents. Right, the agent is something who runs it also a runtime on top of a model. Usually, what you have today, there is nothing in between. How do you describe many agents work in the like in some sort of coordination, but without a runtime as a runtime abstraction? So you can use, for example, any runtime to run these agents. How do you describe that? So we came up with this swarm contract package. It's SCP, and it is actually like a kind of a standard to describe shareable swarm of agents, right? So why did we do that? That I just explained. So like, swarms are hard. Like if you just call multi-agent whatever, like. What it means that you need like prompts, skills, like whatever model choices, orchestration logic to pack everything and kind of transfer it somewhere on another machine or on another runtime, right? So then you have loops also. You have like sometimes you call it Ralph loops. Yeah, the agents execute their routines in a loop, right? You need to describe all of this. So we didn't have any like this didn't exist before. So we create that. You can go to like GitHub gosh.ai, and there is gosh.scp where it's all like open sourced, like as a declarative standard. So it's a declarative swarm package standard which describes everything about how agents should work. Like it's roles, agents, skills, tools, model selection sometimes, because sometimes you want an agent to only use particular model, common schemes, dogs, which is basically like how the process goes, like to describe the workflow, artifacts, data sources, loops, and all of that should be validated somehow, right? Because you want to know if the swarm is actually like if the SCP is actually kind of good, right? So it should be like completely neutral to the provider or like creator of the swarm or runtime, right? And so yeah, should in the end, like if you run this swarm, it should execute, right? So how it works, you can like you can actually give this like Gosh SCP to your agent and say like, this is my workflow, or actually run a workflow in your environment, whatever it is, and kind of ask an agent to just take the SCP and describe it. And I run it on GPT. I run it on Cloud Code. Everyone is doing that pretty fine. Like, of course, they're running validation. They redefine stuff like that. You can test it, but then like anyone can, like your agent can create this. So once it's created, it will create like the runtime imports, validates, and then the artifact loops and all of the process. It will know, like, believe me, it will know. There are pretty good documentation that the agent write one to another. So once you created this, you have a reusable package. It's not a runtime script. So then you need to have a runtime that that can actually execute it, right? So of course, like, okay, we built this runtime, but you can actually go and like ask your agent whatever runtime you use. It can be like OpenClaw or whatever you use. You can ask it to kind of adopt it to run SCP. I know they will if your Swarm, like if your harness is open source, like most of the models will be able to do this. So okay, so now we have we have this definition of agent workflow that we can pass to each other. Now we can actually like publish it on a blockchain. Okay, so that is the next step. So there is inside the repository, there's gosh.akinaki repository, and that repository is kind of a blockchain layer already adopted for this autonomous AI agent. So there is a wallet, there is on-chain payment, and there is like Swarm marketplace, let's put it this way. And by itself, it has an MCP. So like your agent can interact with that using MCP. You can actually take it, install inside your harness and use it. So what is it? So it's an integration model that gives like Gosh AI agent a wallet, on-chain payment, AI model, token marketplace, and it will the agent that like it has a multi-sig inside of that, and the agent will manage it. Like whatever policy, like you can install policy that you want, like who is signing what and so on and so on, right? So autonomous agents must pay on chain, right? And what we want them to pay for is everything they need, including model use. So imagine that you create a swarm, like an SCP definition of a swarm, and you suggest there that I suggest you to use this model with this swarm, and actually you can sell tokens within this swarm that you created. So for example, you can list your API endpoint, whatever your model provider, or you have just a model running on your laptop, whatever. And you have like unused capacity. You can say, all right, I have some tokens. I can sell it within my swarm. The implication of that a little bit farther than that, but we will talk. Just the easiest part. So you put inside your swarm API endpoint of the model and the wallet. Let's call it a wallet. It's a smart contract, basically, where you list the token. So like inference that can come with the package, with a swarm. So you have this MCP server, as we said. You have AI registry, which is like a token marketplace that you can connect to your swarm. You don't need to, but you want. If you want, you can do that. Then there is a budget delegation that basically, like, right, you have 2 or 3 signatures inside the multisig, which is you and your agents, whatever you want to build it. And the integration is like 3-step integration. Again, I integrated inside the harness this whole thing in like a couple of hours, basically. So if you give it to your agent, they will know what to do. Okay, so we have that layer. So we kind of compacted the description of the swarm, abstracted it, put it on chain. Then, like, we created this marketplace on chain where you can list your swarms, and also you can list your endpoints for whatever model tokens, inference tokens you want to sell. Okay, maybe I should say how it works in a couple of words, just in terms of mechanics. So when you list your token, I can search for swarms, and I can search for whatever, if the swarms has the model or token within the swarm. And I can say, oh, I like that swarm, and I like that model. And so I can just import that into my runtime. And what I will do is that if I decided to use your model tokens that you sell, I will do settlement on chain. So I don't need to actually, like, there are some projects I know that are trying to do this, but it's always a kind of, it's either you need to prove the inference on chain, which is what Gonka does, right? So that, like, validators running and proving all the time to the network that they actually run this inference. But when you buy the inference, like, you're not sure really, is that going to be available? So you need to trust the provider anyway. So in a way, this doesn't replace the trust model between you and the API endpoint. What we did is a simple contract where you fund it, and then the provider of the model will deduct some of the tokens all the time, like ticks per use, and you can stop at any time. So you pay a little bit in advance, right? Whatever the tick is, the provider also decide which ticks. Like, it can, of course, do it 1 month if you believe this provider, then just, it's an I'm anthropic, like, I prove that I'm anthropic, I will do 1 monthly, fine, whatever. But if you just don't know who am I selling these tokens, like, probably my tick will be like maybe, million token, maybe like 5 minutes, whatever the tick is, the tick size is. And you decide if you want, like, to fund. So maximum you can lose is 2 ticks. They're like 10 minutes of compute, or like, okay, or 1 million token or something like that. You advance that, and anytime if the tokens are not provided, then you just cancel the next kind of ticks of the subscription. And I am, as a provider of the token, I will just collect the money every whatever subscription period, right? So that's it. So it's on-chain settlement, right? Why it is important? Because we want to abstract everything. We want to make everything trustless. We believe that is what blockchain is for, right? So these things are actually almost cannot be done without blockchain. And if we talk about AI and blockchain, we want to use cases which actually blockchain native. And blockchain native use case, payment is kind of blockchain native, but fiat also is a payment. You can play with credit card. These kind of abstracting trust is really the core of what blockchain can do. So last thing, let's talk about the runtime itself. Like, what is the model? Why actually, like, okay, so you can sell some tokens, fine. That's not everything. What we believe will happen, like, that's basically the vision of the future, if you think. Right now, what you have is, like, you have, well, 2 types of swarms, mostly, like 2 types of harnesses, we'll call it whatever you want. One is the most predominant one, this open AI and Anthropic and Google is pushing very hard, hopefully very unsuccessfully in the future, is the model-centric, modern model-driven, because the model is what they develop, is what you pay for, what basically all their money is, like, they're collecting for the use of the model. They have like one model, more or less, that they really want to push. And because of that, they want all the harness, everything to surround their model, because then you will be vendor lock, right? You will use only their model, you will pay only them. And that's what Anthropic did for the last 4 months when OpenClaw kind of released and became very popular, is trying to kind of, basically restrict the usage of OpenClaw or any other such. Why? Why did they do that? Do you really think it's because the token economy or anything like that? No. It's because this is abstracting the model. Because if I use the kind of a runtime or the harness or a third-party harness, the models will switch. And you will see that the models will actually switch much faster than you think. Right now is like, okay, I choose this model because I buy the subscription for $200 or whatever, which is another way for them to kind of lock you in, right? Because they subsidize a lot of tokens, and we see how their business model cracking. Like they cannot sustain that because it's unsustainable what they're doing. But why they're doing that, losing so much money, where they could actually practically just make a revenue, make a profit or every token they sell, but they don't do that. Why do they lose money? Because of the model learning? No. It's because they heavily subsidizing the use of their model to lock you into this model, right? But we believe in our vision that this is not going to last, primarily because the models will be like, there will be a lot of models basically. And we see that the open source models now becoming better and better and better, and they're catching up. And even if they're not catching up, let's say that the distance will stay always for 1 year. 1 year of a difference. You know what? Even take 2 years. It would be very large. Although now it's 6 months. What will happen? Well, in 1 year, they will arrive where Opus and ChatGPT 5.5 today. So what? Like, right? You will when you cross certain chasm, certain like line of good enough, like you don't need to go. It's okay. Like the difference actually shrinks. It's not becoming more. So we believe that there will be more and more models, and the open source models, and more model providers who will provide good models for a lot of stuff. And yeah, even if they are lacking some like frontier, they will catch up eventually. So the model-driven harness doesn't make sense now. So you have the IO-driven harness. That's what kind of OpenClaw, because basically what you do is you have an agent, and then you have interfaces with different other systems around this agent. That's what the claw movement all about, right? You have you can talk to over Telegram. You can connect it to your whatever like IoT machine, the temperature bar, whatever, and that allows you to do stuff in real life with this model. What we are advocating for, though, it's a little bit different thing, and we call it a data-driven model, where in the middle of the harness of the swarm is actually the data. It's a data that really all of these agents that you run should share first and foremost. And you can call it a memory system, but usually the memory system today, they're kind of attached to your model or attached to your agent. We don't think about this way. We think the memory is in the center of everything. And if you go again, there's Gauche memory repository in there, which would provide you such a system. It's really like your agents you connect your agents to the memory, to this data layer, and the memory itself starts coordinating them. It's not a passive memory. It's just a not passive database where you just ask. It has a subscription model where it pushes the things. So what happens is, and this is the missing piece inside the swarm, the third thing inside the swarm that you can do, you can actually sell expertise. When you create a swarm of agents, you don't only connect it to your token if you want to make some money on the token or connect it to your inference, but you can also provide it with the data. So yes, the SCP is kind of an abstract from the runtime. Any runtime, adopted runtime, can use it, can run it, right? But you, as a creator of a swarm, can actually connect, like give it the data. And through that, so you can sell your tokens and you can sell your expertise via the data that you feed into the swarm. So, like, of course, how do I use the swarm with your data? Like, I take the swarm, I take the data that you provide to run the swarm. It gives the swarm the expertise. And data, by the way, it's not just skills, because skills are very small. It's like there might be a large amount of data that you can kind of provide via the swarm through the memory system. And that swarm can be just a law firm. But the law firm today, like, what is the difference between law firm skill and the law firm? It's the data. It's like, huge amount of data that this law firm possess of all the previous cases and everything, and how to actually, what to do with this data, how to read this data. That is, skills will not do that. And we will see that more and more. And actually, we had the news, like Today News, for example, that the large law firm, I forgot the name, has an Anthropic building with them the law model. So if the skill is enough, why skill is not enough in this case? Because actually it's not enough. The skill is not enough. Sometimes you need a lot of expert data, and who has this data? It's an expert, because that's what expertise is. Because it's not only about raw data. You also need to know how to go about this data, how to read this data, how to analyze this data. And you can now build a swarm of agents that can be used to actually do this. To you run it, and it will provide you the expertise of this person, because this person actually built it through the skills and through everything, but also through some data that it gives it to you. So it's an MCP server connected to the swarm, like a token connected to the swarm, and you can charge for it, charge for the data, exactly in the same way, through the same mechanism as you do with token. That's it. And so what it enables is massive deployment with very minimal exposure, trustless deployment of
massive harnesses of an agents. I thought about doing the live demo of this, but we don't have time. It's 30 minutes it took me. But you can go to the repository and run it yourself. There is an E2E test in the gosh.p. Gosh.p is going to be published, I think, more or less now.
Yeah,
it's a harness that you can run E2E test there, and it will just spawn you this swarm package with 20 agents, and you will see how it works.
Once you send me the link, I will attach that in the show notes, wherever we will be publishing the video, the recording. And whenever anyone is interested in getting the link, just drop a message in our Telegram chat, and I will be providing it there. And let's just quickly go through the questions. We have multiple questions, but I think we will be covering only one, and the rest of the questions can be covered in text, if that will be fine. Just for the sake of time, so that we fit into the time limitations. And the first question says, we get a lot of comments, a lot of compliments. Everyone is happy about seeing Mitya on X, on YouTube, anywhere else. You're pretty famous among our audience too. And the question is, so what are the biggest risks if we let agents have wallets, box prompts, injection, key theft? How do you design safety around that?
There is no good way. Meaning the only good way is don't give it too much money. And we build these tools to help you with that. So you have the multi-sigs, right? So you can create rules. Just create rules inside the harness that tells not only tells but enforce them. So the agent cannot go over this. Doesn't matter what the prompt injection is. If you give it $10 in the wallet, the only thing it can damage is $10. Just don't do that. Just don't give dangerously skip permission to your wallet. You can do it to your computer, but don't do it to your wallet.
That's much more obvious than anyone might have expected. Let's cover one more question out of 3. It says, you said MCP is the current standard. What is missing in MCP that's you're trying to add?
Okay, I understand. The MCP standard the SCP is not replacing MCP. It's a different scope. MCP provides you, you have a server that you want to provide information from the server to the agent. And MCP is there. It's a great standard. We're using that. And actually all the inside our harness is all MCPs, right? But when you want to describe how agent works, for that, there is no standard today. That's all. That's why SCP is great. It's not overlapping.
And let's fit quickly the last one. It says, how is SCP different from just a YAML JSON config for multi-agent workflows?
I explained that. Just look at the presentation. It's actually you cannot do that. It is a JSON in the end based, but you need a lot of rules and a lot of enforcement, a lot of how they connect to each other. It's not enough just describe in
like free form. Because if you just describe it in free form, well, it will sometimes work, sometimes not. It's not repeatable. If you want it to be repeatable, then you need to really almost have to create a DSL language to describe how this works, like step by step, because you want edge. Like right now, the large, like it's in SCP, there is an example of the swarm which has 14 agents, which operates in a very particular way, one after another, doing different jobs and different checkpoints and so on and so forth. Two agents, maybe it's enough just to describe somehow verbally or in JSON. But if you want a step-by-step instruction repeatedly done correctly, then it's not enough.
All right. Yeah, and I think this will be it for the current session. Really, a lot of things to think about. Thank you so much, Mitya. That was really interesting and
Thank you very much.
Looking forward to see you next time. And
Thanks.
yeah, after a very short transition for about 20-30 seconds, we'll be back with the concluding session of the second day of the Blockchain Community Day Conference. So please stay tuned. We'll be back in 20 seconds. All right, so this will be our concluding session of the second day of the Blockchain Community Day Conference. And this time we are speaking about AI native security, the new standards for securing your smart contract development. And I'm happy to invite our today's guest speaker, Alexandra Gulamova. And yeah, hi, Alexandra. We can see you.
Hi, thank you for the invitation. Nice to be here.
Yeah, it's a pleasure. And before we start, just a couple of words about yourself and about your background, please.
Okay. So I'm in blockchain since 2020. And we have launched the 7th chat in February 2025. Before I worked in ZK projects, and now we are building AI security instrument because AI is becoming an important part of our life and workflow, and it's impossible to skip it.
Yeah, really 100% agree with you here. And yeah, I think we can now see the screen, the deck on the screen, and we are good to start. So the next half an hour is yours.
Oh, sorry, there is technical issue. It should be another.
Another deck. No worries. So we can change that quickly. Yeah.
Yeah. Sure. Sorry.
Let's re-upload it.
Yeah. Just a second.
And yeah, in the meantime, I'd like to remind our audience that tomorrow and the day after tomorrow and on Friday, same time, we are going live with another bunch of speakers and other tracks. So please make sure to join. There will be more talks about interoperability, about policy and regulation, about DeFi and finance, and real-world assets. So please, waiting you tomorrow. Same time, same website. Subscribe to our social media channels and join our Telegram chat. Everything will be notified there. And yeah, to those of you who are watching us on the VR community platform, I sent the link to fill out the feedback form. So whenever you have a chance, that will be very useful for us to make conclusions about the conference and about the content we are bringing and about the lineup we are gathering on our events.
So it's uploading now. It should be okay. Just a second.
Yeah, it showed up.
Okay.
Okay.
Yeah. Thank you. So sorry for the technical issue from my side. So as I mentioned before in the beginning, AI becoming a really standard of our life, and it's important part in our private life, professional life, workflow, and do we like it or not? We need to live with it and to work with it. And now I would like to speak about how AI influence one of the sensible and one of the main important part of our life in blockchain is security of our projects, and also I would mention another important part because in security landscape of Web3, there is not also only defenders, but there are also hackers, and it's also an important part of our security life in Web3. So we all remember a significant April 2026 when almost every day we faced different hacks, we faced different vulnerabilities and different type of crimes in Web3 landscape. I think it was never before, and so as you can see on the figures on the slide, the trend is quite increasing and increasing. And why we face this issue? Also, it's important part of this trend that before, more or less, hacks looks like one each other. It was some patterns we could see in different types of attacks, but starting from autumn 2025, we found out that it could be absolutely new, something we have never seen before. New way of attacks, absolutely new, without any patterns. And why it is so? Because AI is developing, yeah. And while defenders try to be quite conservative and try to lay on traditional way of protection and believe that high quality security auditors, high quality in-house process of security can protect us, AI is in cooperation with attackers. So attackers needs to be more flexible, needs to be more fast, and they do. They really use AI instrument, and we can see it starting autumn 2025 because AI has absolutely different perspective on the code. AI has absolutely different ways of attacks, and yeah. So what should we do? We will see next. But we should keep in mind that attackers also develop their instruments and develop their processes. But what is really nice for us is that for hackers available only their personal instruments because all high quality AI instruments that on the market never allow to use it by hackers, obviously, because for example, we in 7chat has a strong pipeline not to allow attackers to use 7chat, and only protectors and auditors and developers are among our clients. And so I think the same situation in other projects also. So the attackers can also use their own instruments, and they need to build it, they need to research it, they need to create it, and they spend time for it, even if it's a big team. Anyway, they need to split their attention, and it's good for us because we are as a defender, and you as a builders can concentrate on your security pipeline and creating your product. Also, if we are speaking about personalized in-house setup and universal AI product, personalized in-house setup anyway will influenced by some habits of developers, some habits of hackers, some it won't be so objective as a universal AI product, because, for example, if we create our product, we keep in mind that there is different styles of developing, different styles of creating code, different styles of different patterns, and we create the universal product that fits every needs. And because we pay all our attention, all our skills, all our experience, and all our time to be on the top of AI industry, and we know the highest standard of AI. While attackers can do it because they also need time for their main work. But what is really threat is that if about attackers is clear, they don't have any choice. They need to take it as is. A lot of builders and auditors follow this way, and it's really stranger, because they can use high quality instruments, they can use the expertise, the experience of people who pay all their attention, time, and knowledge to create protection instruments, but they prefer to create their own instrument. And we should keep in mind that it won't be so widespread, it won't be so objective, and it won't provide 100%. Also, you spend time losing some opportunities for your main work, for creating your code, while another teams who use ready to use instruments, they pay all their time and expertise for their products. Your competitors never sleeps. So keep in mind what is more important for you. We should also consider about bug bounties, because to avoid some patterns, to avoid some the same way of thinking about the code, a lot of teams can say, okay, I will go to the bug bounty platforms, and a lot of auditors will come there, they will check my code, they will provide different vulnerabilities, different weak places of my code from different sides. It could be, but also we should keep in mind about AI, because AI is important part of our modern life. And take, for example, when we have 6 million project. If Black Hat spent 6K for inference to check this code, he will take obviously all of this 6 million, and he it's okay for his economic, even if he spend it for different projects, even if it's 0.1% of success. It's also okay with this mathematic for him. But while white hat hacker also needs to spend for every code he check the same amount. So it's more or less the same amount for each project. But only in one case he will get only 60K or even less, as you know, on bug bounty platforms. So obviously he needs to spend much more than he gets, because only in one project he can get bug bounty, while other projects can be okay. And obviously he will spend inference but didn't get something. And this economic doesn't goes for bug bounty platforms, because obviously it doesn't work any longer. And it doesn't provide any objective side of defenders. So you need to lay on yourself and only on your own pipelines. But let's take a look how it was developed and where we started with security. In 2015, it was manual reviews, so we lay on only third-party auditors, and we spent a lot of time, a lot of money, and it was the only way to know something about security, to increase the security level of the project. Later, static analysis appears on the market, and it was quite good because it was first steps of automatization, and it became more wider protection, and it became more easy for auditors to use. Also, it was easier for developers to use also this instrument during the developing process. It was a big step, but everything changed in 2025 because AI tools and agents appears on the market, and it's absolutely changed the game. Everything now in in a new way. And so, what actually we have in 2026, because AI isn't just one instrument, and more or less it's not just one type of the instrument. We can speak about stock LLMs, we can speak about different cloud skills, specialized AI agent, or even about CI/CD integration if you're really pro in your security process. Stock LLMs, it's first step in for everyone who wants to implement AI in their security pipeline. I think all of us were there. So you just push any prompt and get the result, then prompt again. You spend the time. Every time you have new prompts for new project. Okay. Anyway, it provides some kind of AI perspection of your code. It's better than nothing, obviously. But you still spend a lot of time and get extremely suboptimal result. So if we are speaking about cloud skills, it's much better because professionals had set up for you, and you just implement it. You don't spend so much time for every new audit, but you should keep in mind that it's still general LLMs that can't work properly with security audits. They weren't created for security purpose. It's just a general perception of the code, and it can't catch anything interesting. It still provides extremely a lot of false positive, but it's still better than just LLMs. What about specialized security AI tools on the market? So it's much better, obviously, because it is created by professionals, and it's not just one LLM, because all of them has weak and strong sides. All of them has their specific points, and for example, in 7chat, it could be up to thousands parallel requests to different LLMs only for one audit. So it's impossible to restore for certain audit in any case, because you will spend extremely a lot of time and all your time, and you still didn't achieve these processes that is under the hood in, for example, 7chat. And also it better the result, because you can lay on very difficult architecture that is fine-tuned for catching really interesting bugs. And we found big places in codes even after our clients went to tier 1 auditors. It's not because tier 1 auditors work not so well. No, not at all. They are great professionals and they do their best. But as I mentioned, AI has absolutely different perspective of code, and we should always keep in mind this. But if you are really pro, you can get CI/CD integration in your developing process. So you just integrate it and you get the report during the process of creating code. So you can fix something not after you complete the code and finding different ways of different connections of the different parts of the code. No, you fix as you create it, and it's much faster because you just push the request and then you just get the small report even in your Telegram in a few minutes because it's small amount of code obviously, and you fix it as soon as possible. And of course it's new level of security in your projects. So how the ideal way of security can look in 2026? First of all, you use CI/CD and you go with security during the creating code. On every stage, on every part of the code is checked. But then you check the whole project from time to time in AI. Why you need to do it? Because ICD increase security during the creating of code. But anyway, sometimes we need to have a look for the whole project as it, because also it could be found something interesting when it has a big amount of code. And of course, you need to go to the human audits. It's for major release, so everything like it was before, because human audit is still on the market and it's another way of security. So you can skip it, but you need to prepare it. Also, when you prepare with AI for human audits, it also helps audit to find something interesting, because also auditors use their tools, and auditors also use general tools like 7chat. We have a lot of auditors among our clients. And also it's important to mention about fatal mistakes that could be done in 2026. And first one is treating only one layer of security. For example, if you say that you use CI/CD and you don't need the whole AI audit, you don't need the human audit, you can be attacked and you can face threat from hackers and from attackers, because you have only one side of the security. Also, human audits standalone doesn't work, and we were able to see it a few days ago with Zcash, who just found vulnerability with simple LLM, even not with professional instrument. And we can be sure that Zcash team is extremely professional, and we are sure that they had the best ever auditors can ever imagine on the market. But it's only because AI has absolutely different perspective of the code, and they can see different ways of attacks that people can see, because it's more objective. It doesn't have any standard way of thinking, because it's every time something new. And also, another crucial mistake that could be done in 2026 is trusting cheap AI tools or believe that all AI instruments are the same. Unfortunately, I often see the situation when people came to cheap AI instruments that provide result in a few minutes. So they promise and they do it, upload several thousands of lines of codes, and you will see the result in 10 minutes with almost zero spend. And obviously, you can see the zero result because it's important. It can be cheap. As I mentioned, we make up to thousands requests for different tier 1 LLMs. So it can't be zero spent. Inferences still exist on the market. Yeah, and those people believe that all AI instruments is the same, useless, and they can't do any harm to any code. And it's not the same because hackers use also strong instruments. Yes, it's weaker than protecting side because they need to create something for their own, but it's still not a simple wrapper for cheap LLM as a lot of AI tools provide on the market now. So you should trust really high quality AI instrument and to use only high quality products on the market. Yeah, and remember, keep in mind, build like attackers already have AI because they do and they use it, and we see it on the market every day nowadays. Thank you. I'm ready to answer your question.
Thank you, Alexandra, for such a great presentation that is really very relevant for 2026 and very actual. We have a couple of questions in the live chats, and yeah, let me just quickly bring them up. So the first one says, does your approach do multi-LLM voting / assemble? How do you avoid correlated model mistakes?
It's a difficult architecture, and yes, we use different tier 1 LLMs. All our researchers are specialized with AI. They know their weak and strong sides, and so they balance it one by each other. So, for example, one LLM can create some assumption, another LLM can critique it, and so it could be in different cycles with different perception of the code, and yes, so more or less we're balancing weak and strong sides of different tier 1 LLMs in our architecture by prompting and by each other.
Mm-hmm. And the same person asks, and how do you prevent leaking private code when using cloud AI security tools?
Yeah, it's a really good question, and it's most widespread threat about it. I should say that more or less it's the same as we see the risks while we start using the internet, because before it was absolutely private on our own laptops, in our own papers. When we start, the risks of leaks appears. The same here. From our side, it's strong architecture. If we don't save something as is, so we split the code, and also we use really tier 1 LLM like Anthropic, OpenAI, Google, so they also provide some level of security and prevent leaking.
Mm-hmm. And the last question, what is the best workflow for auditors? Use AI first, then manual, or manual first, then AI?
Among our clients, auditors use both of this perspection. It depends on what you really like. But for me, I think it's better to have first AI and then manual, because that I often listen from our auditors clients that even if AI provides some false positive, for developers is useless information, but for auditors is very useful because they start to searching around this false positive, and they found back something somewhere near this false positive. So also other side who use AI after manual audit, auditors say that it helps them to have a fresh look on the code. So they do all their work by manual. They read this code a lot of times. They can skip something, and then they get AI 7 chart, and so they see something new from the fresh view. But as I mentioned, for me, it's better to use it in the first step, but it still depends on you.
All right, and I see that was the last question in the live chat. Okay. But anyway, yeah, whenever we will be getting new questions, once we publish the recordings of the conference, we will be addressing them to the speakers directly. And please feel free to join our Telegram chat and drop your questions there as well. And yeah, thank you so much, Alexandra, for such a great presentation. Really important points for every.
To join. Thank you. Have a good day.
Yeah,
Bye.
Thank you so much. Have a good day too. And yeah, with this being said, this concludes our today's second day of the agenda of the Blockchain Community Day 2026, and we have 3 more days ahead. And tomorrow, the day after tomorrow, on Friday, same time, please join the same webpage, same social media accounts, same YouTube channel, wherever you are watching this. And yeah, a lot of more topics are yet to come. See you tomorrow then. Don't forget to fill out the feedback form. And bye-bye, everyone. Till tomorrow. Give me that.